So the 2 poles really so, okay, I want to go over the different types. Okay, I want to go over different types of meteorites and what we've learned from them about the formation of Earth and the solar system. The thing is, what's especially interesting about a meteorite is that they come from interplanetary space. They consist of the same chemical elements that are in matter originated on Earth, just in different proportions. That makes it easier to identify something as a meteorite as opposed to just a terrestrial rock. So, to talk about where meteorites come from, we need to talk about comets and asteroids, which basically they're basically made up of debris left over from the origin of the solar system 4.6 billion years ago. Now I'm going a bit over here. I'm not going to go into any depths on the comets and asteroids now, but we'll calculate and do that. For now, I'll just cover some basic info about them. Okay, comets and asteroids. It might help if you think of. Remember we talked about the two crushes of planets in our solar system and how they differ in composition. The terrestrial planets like Mars and Earth compose largely of rock and metals, and the red gas giants like Jupiter's. Well, the solar system also has two analogous crushes of objects smaller than planets, namely asteroids and comets. Relatively near the Sun and the inner solar system, between Jupiter and Mars to be precise, we got the asteroid belt, which contains about 90% of all asteroids orbiting the Sun. These asteroids are like the terrestrial rock planets, and they are composed mostly of rocky materials and metals. Far from the Sun, in the outer solar system beyond Jupiter's orbit, temperatures are low enough to permit ashes to form out of water and out of gases like methane and carbon dioxide. Loose collection of these ices and small rocky particles form into comets. So comets are similar in composition to the gas giants. Both comets and asteroids are typically smaller than planets. And even smaller type of interplanetary debris is meteoroids. And it's from meteoroids that we get meteors and meteorites. Rise for the most part anyway. Earth's atmosphere. Well, that makes them so special that they get a special name. They are called meteors. Most of them are very small, and they burn out soon after entering the Earth's atmosphere. The larger ones that makes it through the atmosphere and hit the ground are called meteorites. Meteorites are the ones that actually make it through. Now will be meteorites on Earth for the thousands of years, and we vandalize enough to meteorite out of the composition. Most come from the asteroids, so the fuel made from comets. So essentially they are rocks, and like rocks, they are a mixture of minerals. They are generally classified into three broad categories: stones, stony ions, and ions. Stone meteoroids, which you refer to simply as stones, are almost entirely rock material. They actually account for almost all of the meteoroid material that falls to Earth. But even so, it's rare to ever find one. I mean, it's easier to find an iron meteorite or a stony ion. Anyone guess why? Look at their names. What do you think iron meteorites consist of? Mostly iron? Yeah, iron and some nickel, most of which are metals. And if you're trying to find a metal, oh, metal detectors. Right, thank you. At least that's part of it. The stone meteorites, if they lie around exposed to the weather for a few years, well, they're made of rock, so they end up looking all of indistinguishable from when they originated in us. So it's hard to spot them by eye. But we can use metal detector to help us find gems, and there is a spot by eye. So most of the meteorites in collections in museums, they'll be the iron meteorites, or the stony iron kind, even though they only make up about 5% of the meteorite materials on the ground.